What's going on, everyone? Welcome back. Patrick here, and moving on to the next example. Notice we're still analyzing categorical variables through a bar graph. So we have this new example. So out of 100 people that we sampled, the number of people that ate each of these fruits here in the past month are given below. So 42 people ate an apple, 60 people ate a banana, 36 of the 100 ate a pineapple, etc., etc. And we got these two questions here to answer. So the first question is, can you represent this data here with a pie graph? Now, if you remember from the video where we talked about pie graphs, I mentioned that not all data can be represented with a pie graph when we're looking at categorical variables. So notice that if we add up all these numbers here, the sum of these numbers is going to be greater than 100. But we only sampled 100 people. So why is that happening? Well, if you read carefully, notice that we're looking at the number of people that ate each fruit in the past month, each of these fruits here. But people can eat more than one fruit in the past month. So there may be people that ate an apple, a banana, and a pineapple. And so they would go into each category. And so the answer to this is no. You cannot represent this data with a pie graph because each category is not mutually exclusive. Mutually exclusive means that if you're looking at certain data, each individual can only be placed in one category. But in this case, individuals can be placed in more than one category. They could have ate more than one fruit in the past month. You could also look at the percentage. So notice 42 out of 100 is 42%. 60 out of 100 is 60%. And just with these two categories, notice it's going to be over 100%. Remember, to make a pie graph, everything is in relation to a whole or to 100%. So if these percentages are greater than 100%, then it's just not going to work out. So to put more detail into this explanation, so no, because each category is not mutually exclusive. And more specifically, in terms of this example, a person, one of the people sampled, one of the 100 people, can eat more than one fruit in the past month. Or maybe a person could have ate. It's better English there. More than one fruit in the past month. Now, how can we make a similar example? So just change this example slightly, the scenario slightly, so that each of these categories here are mutually exclusive. Well, maybe we could say out of 100 people sampled, we asked each person what is their one favorite fruit. They could only pick one fruit to be their favorite. Then notice that each person is going to pick one fruit, and so these categories then are going to be mutually exclusive. And then this number here would add up to 100. Maybe another example would be out of 100 people sampled, we asked everyone what is the most recent fruit that they ate. Assuming that they weren't eating multiple fruits at once, what's the most recent fruit that they ate? Well, each person is only going to be able to pick one fruit. Okay, and then these numbers again are going to add up to 100. The 100 people, or the percentages, if we get the percentages, is going to add up to 100%. And then the categories are going to be mutually exclusive, and then you can make a pie graph. All right, but in this case, with this data, with this example that we're looking at, we can't represent this data with a pie graph because each category is not mutually exclusive. So then number 2, it asked to represent the data visually. And so what we're going to do is represent it with a bar graph. right? If we can't represent it with a pie graph, categorical variables, bar graphs is the only one remaining. And you can represent non-mutually exclusive categories with a bar graph. It doesn't matter if there is overlap. A bar graph you can always use. So to create this bar graph, let me draw out these axes here. So we're going to have the fruit. Remember, the categories, the categorical variables always go on the x-axis for a bar graph. And then either the frequency or the percentage goes on the y-axis. So in this case, we're looking at number of people. The maximum value is 60, so let's go up by tens here. So we'll have 10, 20, 30, 40, 50, and then 60 up there. Let's label this. This may not be necessarily to scale in this video. I'm going to do my best, but if you want something a little bit more to scale, you could use graph paper, or you could use software, which is usually what is used, and you'll get a more accurate graph. So in this case, you can go in this order if you want, the order that's given. What I'm going to do is I'm actually going to go from largest to smallest. So the largest is banana, that's the highest frequency, the number of people. So we would create a bar all the way up to 60. This would be for a banana. Next one would be an apple at 42, which would be about there. And then a pineapple, 36. That's going to be like right there. Next would be strawberry at 25. So that would be, yeah, let's say like right there. And then we would, keep mentioning that blueberry. So, and then blueberry would be last at 20. So 20 would be right there. All right, so took this data, made a bar graph. Remember, each bar has spaces in between it to separate the categories, the categorical variables that you're looking at. And then we have the frequency here, and I went from largest to smallest. So bar graphs sometimes can be a lot more useful than pie graphs, because like in this example, we couldn't represent this data with a pie graph, but with a bar graph, even if these categories are not mutually exclusive, even if there's overlap, you can still represent it with a bar graph.